Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick until the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 4 to the power of x minus 2 to the power of x is equal to 1. So now 4 here, I'm going to rewrite as 2 to the power of 2 to the power of x minus 2 to the power of x is equal to 1. So I simply just substitute in 2 to the power of 2 for 4. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And m and n are interchangeable, meaning this is also equal to a to the power of n times m. And if a to the power of m times n is equal to a to the power of m to the power of n, this means that a to the power of n times m is equal to a to the power of n to the power of m. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of m. So in this case, we can think of 2 as m and x as n. So now if I switch these two places, I get 2 to the power of x to the power of 2. Now I have minus 2 to the power of x is equal to 1. So now I'm going to subtract both sides by 1. These two cancel out. Now I'm left with 2 to the power of x to the power of 2 minus 2 to the power of x minus 1 is equal to 0. Now I'm going to let y equal 2 to the power of x. So now I have y squared minus y minus 1 is equal to 0. So now to solve this, I'm going to be using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is equal to 1, b is equal to negative 1, and c is equal to negative 1. So now I have negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1 all over 2 times 1. So now this is equal to 1 plus or minus the square root of 1 plus 4 all over 2 times 1 is 2. And now this is equal to 1 plus or minus the square root of 5 over 2. So now this gives me two solutions. I have 1 plus the square root of 5 over 2, and I have 1 minus the square root of 5 over 2. However, this is the value of y. Remember that we set y equal to the power of x. So now, let's first start with if y is equal to 1 plus the square root of 5 over 2. So we know that y is equal to 2 to the power of x. So if these two are equal to each other, then we have 2 to the power of x is equal to 1 plus the square root of 5 over 2. So now, to solve this, I'm going to take the log on both sides. So now I have log 2 to the power of x is equal to log 1 plus the square root of 5 over 2. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can move this exponent b to the front. So this can equal b times log a. So in this case, for log 2 to the power of x, I can move x to the front. So this is going to equal x times log 2, which is equal to 1 plus the square root of 5 over 2. It's going to equal log 1 plus the square root of 5 over 2. Now, if I divide both sides by log 2, these two cancel out, and I'm left with x is equal to log 1 plus the square root of 5 over 2 over log 2. So now this is the same thing as log base 2 of 1 plus the square root of 5 over 2. Because if I have something in the form log a over log b, this is simply equal to log base b of a. So this is my solution. Now, remember how there was another solution. If y is equal to 1 minus square root of 5. So if this is true, then I have 2 to the power of x is equal to 1 minus the square root of 5 over 2. However, 1 minus the square root of 5, that's going to be negative. And this means that 2 to the power of x has to equal a negative number. And you can't take the power of a positive number and make it a negative. So, meaning this has no solution. So our only solution is x is equal to log base 2 of 1 plus the square root of 5 over 2. Now, right here, I want to find the value of x. So to start, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, 3 to the power of x plus 1, this is going to equal 3 to the power of x times 3 to the power of 1. And this is equal to 12. Now 12, I'm going to rewrite as 3 times 4. And now, as you can see, since both sides have 3 in them, I'm going to simply divide both sides by 3. So then these two cancel out and these two cancel out. And now I'm simply left with 3 to the power of x is equal to 4. Now 4 here, this is the same thing as 2 to the power of 2. Now if I take the log on both sides, I have log 3 to the power of x is equal to log 2 to the power of 2. Now if I have something in the form log a to the power of b, it's going to equal, well, I can now move my exponent b to the front. So this is going to equal b times log a. So in this case, log 3 to the power of x, I can move x to the front, and log 2 to the power of 2, I can move 2 to the front. So these are going to equal x times log 3 and 2 times log 2. Now I'm going to go ahead and divide both sides by log 3. So then these two cancel out, and now I'm going to be left with x is equal to 2 times log 2 over log 3. Now, the value for log 2 is equal to 0.301. And log 3, this is equal to 0.4771. So now I have 2 times 0.301 over 0.4771. Now 2 times 0.301, that's going to equal 0.602 over 0.4771, which is equal to 1.26. So this is my answer. Alright, so in this problem, I have 9 to the power of 9 divided by 9 to the power of 9 divided by 9 to the power of 9 divided by 9 to the power of 9. So what I'm first going to do is I'm going to simplify this in parts. So let's first simplify 9 to the power of 9 divided by 9 to the power of 9. Well, 9 to the power of 9 divided by 9 to the power of 9, that's simply just 9 to the power of 9 over 9 to the power of 9. So I have this divided by 9 to the power of 9 divided by 9 to the power of 9. Now, remember, we have to go in order, because remember, PEMDAS, we would have to go in order. So we can't just simply switch these out. We can't just do this divided by these two. We have to go in order. So what comes first is 9 divided by 9 to the power of 9 divided by 9 to the power of 9. So anything divided by itself is 1, so these two cancel out, and I'll be left with 1 divided by 9 to the power of 9 divided by 9 to the power of 9. Now again, you would have to go in order now. So now we're going to do 1 divided by 9 to the power of 9. So 1 divided by 9 to the power of 9, this is equal to 1 over 9 to the power of 9. Now I have this divided by 9 to the power of 9. Now, if I have something in the form 1 over a to the power of n, this is the same thing as a to the power of negative n. So 1 over 9 to the power of 9, that's going to equal 9 to the power of negative 9. Now I have this divided by 9 to the power of 9. So now, let me clear out this page. I have 9 to the power of negative 9 divided by 9 to the power of 9. Now, this is the same thing as 9 to the power of negative 9 over 9 to the power of 9. And now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So in this case, 9 to the power of negative 9 over 9 to the power of 9, this is going to equal 9 to the power of negative 9 minus 9. And negative 9 minus 9, that's simply equal to negative 18. So now I have 9 to the power of negative 18, which is equal to, well, 9, this is the same thing as 3 squared. So I have 3 squared to the power of negative 18. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So, three to the power of 2 to the power of negative 18, this is going to equal 3 to the power of 2 times negative 18. And 2 times negative 18 is negative 36, so I have 3 to the power of negative 36, which is equal to 1 over 3 to the power of positive 36. So this is my answer. Alright, so in this problem, I have 6 divided by 2 times 1 plus 2. And this is actually a very simple algebraic problem that many people actually get wrong. So to solve this, what I'm going to use is PEMDAS. PEMDAS. So the P here, this stands for parentheses, the E stands for exponents, the M stands for multiplication, the D stands for division, the A stands for subtraction, and the A stands for addition, and the S stands for subtraction. So we have to go in a certain order. So what we first start with, we start at the top, and we first look for parentheses. So if something is in parentheses, we solve that first. Well, as you can see here, 1 plus 2, this is in parentheses. So 1 plus 2, that's equal to 3. So now I have 6 divided by 2 times 3. And 2 times 3, this is written like this. Next, well, again, now, we again look for parentheses. There are none. So now we go down. We go down to exponents. Are there any exponents here? No, there aren't. So now we're going to go down to multiplication. And for multiplication and division, although it's written like this, these two are actually in the same box. And same goes with addition and subtraction. So whichever one out of these two comes first, multiplication or division, that's the one that you're going to start with. So right here, as you can see, going from left to right, we have division, meaning we're going to use that first. So now I have 6 divided by 2, which is equal to 3. So now I have 3 times 3, and now all we have left is multiplication. 3 times 3 is 9. So 9 here would be our answer. Now, what people used to do to get the wrong answer actually is, this was actually during the 1900s, what they would do is they would use the right method. They would first start by adding 1 plus 2 in the parentheses, so this would be equal to 6 divided by 2 times 3. But now, instead of doing 6 divided by 2, they would do 6 over 2 times 3. And 2 times 3 is 6, so they get 6 over 6, which is equal to 1. And this is actually the wrong method because, as we know, we do, between multiplication and division, we do whichever one comes first. So in this case, division comes first, so we would do that before the multiplication. So that's how you solve this problem. All right, so in this problem, I have 2 to the power of 18 minus 16. So to solve this, what I'm first going to do is I'm going to rewrite 2 to the power of 18 as 2 to the power of 9 times 2, because 18 is equal to 9 times 2. So now I have 2 to the power of 9 times 2 minus 16. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So in this case, 2 to the power of 9 times 2, I can write as 2 to the power of 9 to the power of 2. Now I have this minus 16, I'm going to write as 4 to the power of 2. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So let me just clear this up real quick. I have 2 to the power of 9 to the power of 2 minus 4 to the power of 2. And remember, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. In this case, a is 2 to the power of 9 and b is 4. So this is going to equal 2 to the power of 9 plus 4 times 2 to the power of 9 minus 4. Now, 2 to the power of 9 is equal to 512, so now I have 512 plus 4 times 512 minus 4. 512 plus 4 is 516, times 512 minus 4 is 508. So I have 516 times 508. So now to solve this, 516 I'm going to rewrite as 500 plus 16, and 508 I'm going to rewrite as 500 plus 8. So now to solve this, I'm going to distribute the 500 and the 16. 500 times 500 is going to be 250,000. 16 times 500, that's going to be 8,000. 500 times 8, that's going to be 4,000. And 16 times 8, that is going to be 128. So, now to simplify this, 8,000 plus 4,000 is 12,000. 12,000 plus 128 is 12,128. And 250,000 plus 12,128 is 262,128. So, this is my answer.